the session. I'm sharing my screen. Please confirm if you are able to hear me properly and see my screen so we can continue. Can you hear me and see my screen? Hello. Okay, good. So, welcome to the mechanics class. As you know, um, we are currently studying some problems from the dynamics and combination of kinetics and kinematics. Okay. In last session, we have studied majority of the problems which are based on the D'Alembert's principle and mainly calculating the acceleration, velocity, distance traveled, and also the force or tension in the strings, etc. Okay. Uh, in the today's session, we will focus more on work energy um, principle problems. Okay, and I would like to give also some introduction about the collision. Okay, what kind of different scenarios will be there, and um, we have anyway solved problems on collision. I think last to last class, but little bit of more background I'll give, and in the next session we will study the remaining topics. So I am expecting this next week will complete your syllabus. Okay. So with that, let's continue the session with some more problem. I have given you this problem for homework. Was everyone able to solve it, or you want me to solve it now? You just have to apply the equations of the equilibrium, and then you will get the answer. Have you solved it? Okay, let me just help you out if you are not. So in this case, if you apply the summation around the horizontal axis, or sorry, along the string, what you will get tension is upward minus W cos of 30, which is acting downward, minus W by G an is again acting downward, is equal to 0. So from this, tension is given as 3 times the weight minus W cos of 30. So it's 0.866. 0.866 W minus W by G, and an is V square by R. Okay, V square by R is 2.5 equal to 0. So you have the W value, right? Um, and you can just calculate it. If you take, or W is not given, right? Yeah, but you can take common and cancel it out. So 3 minus 0.866 will be equal to, or multiply by G, multiply by 2.5 is equal to V square, and so V is equal to, you will get around plus or minus 7.23 meters per second. Okay, here you just have to take the W common and cancel it out. So 3 minus 0.866 into G into 2.5 is equal to V square. This is the equation you will get, and you just have to take a root of it. That's all. So you'll get this answer for V. Similarly, for the tangential force, if you do tangential acceleration, at, so mass times at. Let me just go to the next slide. What we have is mat, that is, you can say as w by g. At is equal to the sine component of the weight, right? Sine of 30. Look at the figure. So this has to be equal to this. Yeah, and here also you can cancel out w. And at you can calculate as g sine of 30. So at will be equal to 4.905 meter per second square. Okay, and an, an is equal to v square by r. V square is 7.23 whole square divided by r is 2.5. So you'll get 20.93 meter per second square. Okay, so you should be able to solve these kind of problems as well, where um, uh, you have to deal with not just a single acceleration but two components of the acceleration, that is tangential and normal. Okay, so let's start some questions on work energy principle. You are already aware of it. What is work energy principle? So you should be able to solve it. We have already solved some questions on it. So it is just an problem solving session for you. Okay, a pile driving hammer of mass 500 kgs falls through a height of 3 meter on a pile of negligible mass. Also, if it drives the pile 1.2 meter into the ground, find the average resistance. Find the average resistance of the ground for penetration. Okay, um, think on this. So we have a pile driving hammer of mass 500 kg, and it is falling through certain height of 3 meters. Okay, and on a negligible on a weight negligible mass pile, you can say, and if it drives the pile 1.2 meter into the ground, um, they are asking us to find the average resistance of the ground for penetration. Yes, try to solve it. I'll give you one minute of time. You solve it and post your answer. Mhm. Okay, let me help you out. See, like hammer is falling from certain height. So initial kinetic energy of pile driving hammer is, you can say, Ke1 is 0. Okay. Um, and final energy of this pile driving hammer is also 0. Okay. Because at the end also it is not, let's say, um, uh, what you can say, in the motion, right? It is again stopped. So Ke2 is 0. Change in K is 0. So basically, okay. Change in kinetic energy is 0. What we know is work done is equal to change in kinetic energy. Okay. Or work done is equal to change in the energy, you can say. But what is total work done in this case? Work done is not just the work done by the hammer, but also the work done by ground resistance, you can say here. So W should be written as work done by hammer plus work done by ground resistance. Okay. And how much work done hammer is doing? The weight, that is the mg will be the weight of the hammer and how much distance it is traveling. um, uh, h1 plus h2, you can say. Okay. um, 3 meter it is traveling, let's say this is the hammer, this is the pile something. Okay. And this is the distance given as 3 meter, and later it goes deeper inside again after hammering, which is 1.2 meter. Okay. So I would say this has h1, and let's say this has h2 is equal to 1.2, sorry. So we can say that weight is mass times acceleration due to gravity. H1 plus h2 is the work done by the hammer, right? And the work done by ground resistance is, let's say, R is the resistance by the ground, and it will give resistance only for this h2, because before that hammer is not in contact with the pile. So the only distance traveled by the pile is h2 against the ground resistance. So that's why R is into h2 we are considering, and it is equal to 0 because work done is equal to change in kinetic energy. So from this, R can be written as minus mg h1 plus h2 divided by h2. Okay. So that is equal to minus 500 into 9.81 into 3 plus 1.2 divided by 1.2. And if you solve it, you will get around 17 kilonewton. The minus sign indicates that it is opposite to the work done. The direction of this force is opposite to the weight. So you can remove this and say it as upward. Okay. 17.16 kilonewton is the resistance of the ground for the penetration, and the direction is upward. Okay. Any doubt in this question? Okay. If it is clear, then let's move towards next. Okay. Little bit different. Using work energy principle again. Okay. Maybe I'll give you two questions which are linked. Let's start with the first one. The distance B will fall below from the rest below from the rest to reach velocity of 2 meters per second. Full stop. Neglect weight of the pulley and friction at all surfaces. Let me help you out with the figure here. A, which is 50 kg mass, it is attached to through pulley to weight B, which is 80 kgs. The tension in the string, and this is smooth pulley. Okay. So this is the diagram. I'll repeat the question. The distance B will fall below from the rest to reach velocity of 2 meters per second. So this, how much distance it has to be traveled? Okay, that you have to calculate. Um, um, let's call it as a D for S. Okay, in order to achieve the velocity of 2 meters per second or 2 meters per second velocity. Okay, so here we first of all we'll solve the problem without considering the friction, and in the next the same problem we have to solve with considering the friction afterwards. So I expect like at least without friction you try to solve, um, then because it will not be that difficult. Yeah, anyone have got the answer or not yet? Yeah, and maybe I'll wait for 1 more minute. It's not that difficult. Distances, wherever distance is mentioned in the problem you have to solve with the work energy principle. Whenever the acceleration is supposed to be calculated or involved, you have to use the D'Alembert's principle. Okay, so remember, and wherever the time is mentioned, okay, then you can think of the impulse momentum principle. Okay, so these are the this basic logic you should know. Mainly, the distance is involved in the question or supposed to be calculated. Work energy principle. If they are asking you to calculate some things related to the acceleration, then D'Alembert's principle will help you. Okay, so keep this trick in mind. In exam, you should not be confused in between, like which method I should be applying here. Okay, if no one is able to solve, then maybe I'll help you out. See, we are not considering any friction. Initially, they have what they have mentioned is the distance b will fall below from the rest. So initial velocity is 0. So I will say initial kinetic energy is 0. Okay, and how much amount of work has to be done? Uh, some distance s has to be traveled, and which is the driving force? The tension in the string, you can say, is the driving force, right? So work done is equal to, especially if you talk about the block A, work done, let's say for block A first, okay, work done will be equal to tension into distance yes traveled. Okay, and what is final kinetic energy? If the block B is moving with 2 meters per second, block A will also move with the same velocity. Okay, so K1 this is, and K2 final kinetic energy, and that will be equal to 1 half ma into v square. So I'll say it as 1 half into 50 into acceleration is sorry, velocity is 2 square. So it's 100 joule. The change in kinetic energy is nothing but the work done. So I'll say T multiplied by S is equal to 100 minus 0. So if you know the tension in the string, you will be able to calculate the distance. Okay, so T dot S is equal to 100. Okay, that is the first part. So if you consider now block B, we can clearly see here again kinetic energy 1 is equal to 0, and kinetic energy of second block is 1 half mv square, that is 80 into 2 square, and that is 160 joule. Okay, and work done in this case is how much? Work done will be different here. Why? Because if you look at the block is like this, weight is acting downward, tension is upward. So work done is equal to W into S minus tension into S. Okay, so tension is acting in the upward direction, weight is acting in the downward direction, and this entire stuff or body is moving in downward direction, right? So total work done is W minus T times S. So you can write it as a W S minus TS. So it is 80 into 9.81 into S minus TS. Okay. Um. Yep. And so work done is equal to change in kinetic energy. I would say it as 160. Not it is joule. 160 joules is equal to 80 into 9.81 into S minus TS. So T minus T into S. Okay. So from this again, you will get, or let's say the previous equation, what was TS? TS equal to 100, right? T times S is equal to 100. You can use that and put it here. So 160 is equal to 80 into 9.81 into S minus 100. Okay. So 260 divided by 80 into 9.81 will give you the value of S. Okay. And it will be around 0.33 meters. So this is the answer for this question. Okay, any doubt? It's very simple. Now, little bit of complexity to it. Same question you have to solve. Here, I expect you have to solve now because um, you know the process now. Just little bit of difference here. If the frictional force, let me go to the next slide. If the frictional force, okay, the frictional force of 49 Newton opposes the motion of a motion of a find the time required now. Okay, a little bit different. Time required for B to reach a velocity 2 meters per second. Okay, same problem. Um, just things are slightly changed. We got one frictional force and for body A, and rather than asking distance, now they are asking you the time. Solve it. Okay, we got. Okay, Vidhi, I'll go to the previous problem once we solve this. Okay. So, or it's not even needed because we are solving the same problem. Let me help you out. So here we have a pulley. Here we have a mass A, and like this we have a block B here. Okay. So in previous problem, the question was the distance traveled by B. Okay, S. Okay, to reach velocity 2 meters per second. Okay. So it was very simple. We started with a free body diagram of block A, and we know initially it was rest, and afterward it has moved by distance of 2 meter, because block B is also moved by downward by 2 meter, means block A also has to move by 2 meter. So initial kinetic energy is 0 because it is at rest. Final kinetic energy is half of m v square. Sorry, the distance we don't know, velocity we know, that is 2 meter per second square. So half of mv square. So 100 joule is the kinetic energy once it reaches the 2 meters per second velocity, and the initial kinetic energy is 0. So change in kinetic energy is 100 minus 0, that is 100, and that is equal to the work done. Work done for this is only force which is driving it is the tension in the string, because it is not having any frictional force or something. So tension in the string multiplied by distance travel is equal to 100. Okay, so tension is also unknown, and s is also unknown, that is the distance traveled. So in order to calculate it, we have drawn the free body diagram of block B. In block B, we can see the motion is downward, right? But which is the driving force for this work done? That is W minus T. So work done is equal to W minus T into S. S is the distance traveled. So W minus S, W into S minus T into S is the work done. And again, the kinetic energy is first initial kinetic energy is 0, final kinetic energy is half mv square, which is 160. So 160 minus 0 is 160, and that is equal to W we know 80 into 9.81 into S minus TS, which we have calculated previously, that is 100. And since it is a frictionless pulley, we can directly put here 100. Otherwise, this term will get changed. Okay. And yeah, that's all. From this, we calculate the value of S. Is it clear, Vidhi? Any doubt in the first question? Um, Now, the only thing will change is like the tension is not same. Here, let's call it as T minimum, and here you have the T max. Okay, and this is no, sorry. Here tension will remain same because they have given only the frictional force for block A, not for the pulley. So only change here is we got a frictional force of 49 Newton. Problem is same. Let me help you out. So let's draw the free body diagram of block A. Here is the tension like this. Here we have 49 Newton force. So this is block A. The work done by block A in order to move by distance S is tension minus 49 times W, and that is equal to change in kinetic energy, and we already calculated change in kinetic energy, that is 100 minus 0, right? So here we got this one equation, sorry, T minus 49 into S. So this implies T into S is equal to 100 plus 49 into S. Okay, I hope it is clear till this. Now if you consider the second block, weight is acting downward, tension is upward. So here again same, weight minus tension time S is equal to change in kinetic energy, which is 160, which we have already calculated. So I'll not repeat it again. So here W into S. What is W in this case? That is 80 into 9.81. So let's write it as 784.8 minus, sorry, into S. Minus TS. What is the value of TS? Minus TS is equal to 160. So 784.8 into S minus TS is 100 plus 49 into S is equal to 160. So this equation will give you the value of S. 784, or let's say S is equal to 260 divided by 784.8 minus 49. And this will give you the value of 0.3534 meters. Okay, and now you got the value of S, but what they are asking is the time. But you know the relationship between the distance, velocity, when acceleration is there. So that is v square minus u square is equal to 2as. The velocity it is achieving is 2 meter per second square. Initial velocity is 0. The acceleration with which it is moving is we have to calculate, and the distance is 0.3534, and this will give the value of acceleration. 4 divided by 2 is 2 divided by 0.3534 will give you 5.66 meter per second square. And now you can apply v is equal to u plus at. V is 2, u is 0 plus 5.6 multiplied by t. You'll get the value of t as 2 divided by 5.66, and that is equal to 0.3534 again. Okay, second. I hope it is clear. Is it clear to you all? Any doubt? Same question, slight change we have, especially in the free body diagram of body A, and the calculating the work done in that case. Any doubt? Okay, if no doubt, then let's move towards next slide. Before we jump into some questions, some more questions, let me give you some little bit theory part. We have studied collision, right? Collisions or impact, you can say. What is meaning of collision or impact? Anyone? What is, let's say, a collision or impact? You can say it is a short time phenomenon. It is a short time phenomenon in which momentum of the individual body undergoing collision changes significantly. Okay, we have studied how the, let's say, law of conservation of momentum works and all, but one point which I have not explained you before is the point E. What is E? That is coefficient of restitution. And in some questions in which they may involve the value of E, so you should be able to handle those kind of problems. So that's why the theoretical background of this coefficient of restitution is important. Okay, coefficient of restitution is nothing but velocity of separation, velocity of approach. You know this concept, say separation and approach, we have already studied. Let me recall it again. Okay, velocity of separation and cost of the large force acting over a short period. Yeah, that is impact, you can say, or impulse, you can say that. You can say it as impulse. Collision means two moving bodies basically uh, in during a short time, if they collide over each other, or let's say um, face each other, and then or you can say impact on each other, um, and their momentum will change. Okay, so this phenomenon you can call it as collision. Okay, so before I jump into this velocity of separation and velocity of approach, the value of E can be, let's say, different. There are three types of collisions you can say. That is perfectly elastic, where the value of E, that is this coefficient of restitution is 1. Another good situation could be uh, perfectly inelastic, or let's say plastic, where the value of E is 0. And third one is perfect partially elastic, partially elastic. So the value of E is lying in between 0 to 1. Okay, either it is a plastic collision, or or you can also call it as inelastic collision, or it is elastic collision, or in between this, partially elastic. Okay, okay. So let's start with the first, the partially elastic, perfectly elastic collision. Simple one. See, if nothing is given, you have to assume this as a perfectly elastic. Okay, and the problems which we have solved previously is under the same assumption, because nothing else is mentioned about the value of E. Okay, but in case they mention something about E, you should be able to handle the problem, and that is the reason we are studying it. Okay. So what is basically the elastic, you can say? What is elastic? You can say it will, the recovery of the shape will be there even after the deformation. So whenever the initial kinetic energy is equal to the final kinetic energy, then that kind of collision is called as perfectly elastic collision. When initial kinetic energy is equal to final kinetic energy, okay, such a collision is called as perfectly elastic collision. Okay, assume you have a mass m1 which is moving at u1, and another mass m2 which is moving at u2. Okay, um, and if they collide over each other. Okay, um, so basically in elastic collision, what will happen? They will collide, they'll deform, and then they'll regain their original shape, and so hence the kinetic energy is conserved here. After, let's say, this collision, the velocities might change. The velocity of this m1 will become, let's say, v1, and the velocity of m2, let's say, is v2. Okay, so what is happening here? Try to understand. Suppose um, u1 is greater than u2. What should be the value of v2, which will be greater here? Then in that case, v2 will be greater than v1. Okay, let me help you out with the complete equation so that you will understand. As you know, the momentum is conserved. Okay, law of conservation of momentum we have considered, studied before. So using that, you can write it as m1 u1 plus m2 u2. This is the total momentum of the system before impact or the collision, is equal to m1 v1 plus m2 v2. That is the total momentum of the system after impact. This should be same. Okay. Um, Mass is also remaining same. M1 is not, M1 plus M2 is before impact and M1 plus M2 after impact. That is also not law of conservation of mass. Mass is also not changing. Momentum is also of the entire system. It will remain same. Though the velocities will change, the overall momentum will remain same. Okay. Same about the kinetic energy. 1/2 m1 u1 square plus 1/2 m2 u2 square is equal to m1/2 m1 v1 square plus 1/2 m2 v2 square. Okay. So you can call it as a first order equation, and this is a second order equation. Okay. So if you solve these two equations, ultimately what you will come up with is this u1 minus u2 is equal to v2 minus v1. What is u1 minus v2? This is nothing but the velocity of approach before collision. Okay. So I hope now you understood what is the value of E. E is velocity of approach, and that is, this is u1 minus u2, and this is the velocity of separation, which is after impact or after collision. Okay. So E is equal to 1 means in this case velocity of separation divided by velocity of approach is same. Okay, and that is what we are saying. Okay, after you solve that equations, those two equations which I have given you on the previous slide, you should be able to get this relationship. Okay, let's try to understand some special cases in this. Okay, if m1 is equal to m2, what you conclude about the velocities? Can anyone tell me about the velocities? Let me go to the next slide here, and I'll write the three situations which I wanted to discuss. One first case is m1 is equal to m2. In this situation, can you tell me about u1, how it will look like, and how the u2 will look like? Also, second situation, for example, the second body is fixed. Okay, and u is in the direction u1. Okay, here u2 is 0. Can you tell about the v1? And the third situation is if again the second body is fixed and first body is coming with a velocity u, making an angle theta. Okay, how the v will look like, how the velocity will look like. Okay, yes, you can type your answers. Yes, velocities will alter, right? Correct, Vaibhav. So v1 will be equal to v2 bar, and v2 bar is equal to v1 bar if masses are same. In the second situation, second body is at rest, so it is fixed, so it is not changing. So u1 is in this direction, v1 will be again in the opposite direction. So you can say u1 bar is equal to minus v1 bar. So their directions are different, that's all. If a body is coming with certain angle theta colliding on a body which is fixed, then it will again go away from that body, making the same angle theta. Okay, so this angle theta will remain same for the v1. Okay, that is what you should know. So these are just basic things. Yes, correct. Coming towards the second scenario, that is perfectly inelastic or plastic. Or plastic. In this plastic collision, in this E is equal to 0, okay? So what is the meaning of it? When two perfectly inelastic bodies moving along the same line collide, they stick to each other. When two moving bodies mm, or when two perfectly inelastic bodies moving along the same line collides, they stick to each other. They stick to each other. Um, okay. Basically, they deform, you can say. They are sticking to each other, means they are deforming, and then you call it as a plastic collision. So, as I said, mass m1 moving with velocity u1, it's colliding with mass m2 moving with velocity u2, and after the impact, let's say m1 plus m2 is the combined mass moving with velocity v. Okay, like this, for example. Uh, yeah, okay. Just give me a minute. Yeah, sorry. So m1 plus m2 moving with velocity v. So how the equation will look like? M1 u1 plus m2 u2 is equal to m1 plus m2 times v. Okay. In this case, kinetic energy before, whether the kinetic energy before impact will be equal to the kinetic energy after impact or no. No, in this case, there will be loss of kinetic energy. Okay. So kinetic energy loss will be there, and that will be equal to KI, initial kinetic energy, minus final kinetic energy. Okay. And that will go into the deformation of the uh, bodies. Okay. So write down KE loss in this case is initial minus final. And the last one, that is partially inelastic. Let me explain you how it will look like. The last one is the third one, partially elastic. Okay. So basically two bodies, M1 moving with velocity U1, another body M2 moving with velocity U2. After the impact, they will say deform a little bit and they'll regain their original shape a little bit. So okay, so it's a combination of deformation. So they will have some deformation, and in previous case the complete deformation is there. They will not regain their own shape. So here a little bit of deformation, I would say, like maybe for example M1 V1 M2 V2. Okay. So m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. That is always there, velocity law of conservation of momentum. But in this case, the velocity of separation, that is v2 minus v1, is equal to e times velocity of approach. That is v2 minus v1 is equal to e times u2 minus u1 or u1 minus u2. Okay, so this is what you should know. This is, and the previous case, the final velocity is v, so v2 minus v1 is 0. Okay, so basically final velocity v2 minus v1 is 0 in this case, and that is what we are calling it as v. Okay, that is the reason. I hope it is clear to you all. Okay, so in case the terms such as e, that is coefficient of restitution, comes into the question, should not able to you should not worry. Okay, same approach what we have used previously, you have to use, just the value of e will make slight change in the problem, that's all. Okay, I hope it is clear. Okay, let me bring some more questions. A train of mass 250 ton starts from rest and accelerates up to incline, accelerates up an incline of 1 in 100. Okay, so 1 in 100, incline of 1 in 100 means for height 100 is the diagonal. Okay, remember, so they are talking about sine of alpha is equal to 1 by 100. Okay, just to avoid the confusion. Okay, attaining a speed of 45 kilometer per hour, 45 kilometer per hour after traveling 250 meters, full stop. The frictional resistance to motion is, the frictional resistance to motion is 30 kilonewton. Find the work done by locomotive. This is the first part. Find the work done by locomotive. And the second part is tractive force assuming constant tractive force. Okay, so two things you have to find it out. Yeah, okay, so you know already the way to solve it, drawing the diagram, free body diagrams and all, so I'll not go into the details. Okay, you have to solve it. I'll wait for 1 or 2 more minutes and wait for your answer. Yeah, you should be able to solve this. Yeah, solve it. Yeah, anyone have solved? One more minute, I'll wait. You should solve it. Not that difficult. Okay. And yeah, one more thing I would like to tell you is like whatever things which we have studied in linear, and some questions we have solved in angular as well, right? So in angular, if it comes, you don't have to worry. Okay, similar approach you have to follow as what we are using in linear. So you may get in exam some problems, let's say, which are related to the constant acceleration and variable acceleration, but in the uh, but it's not a linear acceleration. They'll ask about the angular acceleration. Okay, so approach is similar. Whatever formulas for constant acceleration we are studying, like v is equal to u plus at, s is equal to ut plus half at square, and all the same formulas are applicable in angular acceleration as well. Just their way of writing is different. Okay, so you should not worry about that. The same approach you have to follow when the question is given in terms of angular coordinate system. Okay, that is one point you should keep in mind. Yeah, okay. Let's solve this question. and then maybe I'll come to what I was talking about, linear and angular. See, the question is like this. We have the surface with angle alpha, and alpha is um, tan alpha is 0.01. Okay, weight is acting downward. This is also alpha, W cos of alpha. Okay, and here we have W sine of alpha. Here we have tractive force. Okay, the frictional force is in leftward direction. Here we have normal reaction. Okay, uh, starting from the rest. So the train of mass 250 tons is starting from the rest and accelerates upward on this inclined plane, attaining the speed of 45 kilometer per hour. So basically u is 0 and v is equal to 45 into 5 by 18, or 1000 divided by 3600 will give you the value of v. Okay, and how much distance is traveled? It travels a distance of 250 meter. Okay, um, s is equal to 250 meter, that is given. Also, frictional force, how much? The frictional resistance to the motion is 30 kilonewton. Frictional force is 30,000 newton. Okay, so if you apply the work energy principle, work done is equal to change in kinetic energy. How much work exactly is um, causing this change in kinetic energy is this traction force, or Ft. Let's call it as Ft. Ft, tractive force, minus mg sin theta, W sin theta component. Okay, let's call it as mg sin theta, and minus frictional force. This is the force which is causing a displacement of s for change in the kinetic energy of this half of mv square minus half of mu square. Okay, so in this equation 1, if you put the values, you should be able to get the answer. So Ft minus, what is mg sin theta? It's a 25 250 ton. So 250 into 1000 into 9.81 into sine of theta is 0.01 minus 3000, that is frictional force, into 250 meters is the distance traveled, half of m. Again, mass is 250 into 1000. Okay, 12.5 square minus 0 square. Okay, so yeah, this will give you the answer. Ft, tractive force, is around 132650 Newton. And if you put into this work done, work done is what? Ft into S, that is, or you can call it as 132.650 Newton. Work done by locomotive is 132.65 into 250, and that is 33162.5 kilonewton meter, and you can also call it as a kilojoule. Okay, 33162.5 kilojoule. Okay, I hope you are following it. Vaibhav, you understood the problem? Have you corrected the solution? Okay. Let me check if I have any other problem. Okay. See what I was talking about the problems related to the angular accelerations. Maybe simple questions I'll give so that you will understand what I'm talking about. Okay. So basically, what I'm talking about is u is equal v is equal to u plus at. You also know um, s is equal to half of at square. Okay. And what was the other formula? V square minus u square is equal to 2as. All these formula you can write in terms of angular velocity and angular acceleration as well. Okay, so these formula are applicable for constant acceleration, and we generally use this term v u a in linear uh, coordinate system, right, or linear problems. When a problem is in angular coordinate system, things are same, but their way of writing is a little bit different. So omega is equal to omega naught plus alpha t. Okay, I have explained all this before, that what is omega. So distance is more or less like theta. Omega is more or less like velocity, and alpha is the acceleration. Okay, so these terms you have to just replace with the theta, omega, and alpha. Okay, we have studied this in fixed axis rotation topic. So just to recall how the equations will look like, theta will look like as omega naught plus half of alpha t square. Okay, and same here, omega square minus omega naught square is equal to 2 alpha t, 2 alpha theta. Okay, so you don't have to worry when problems are in this format. Um, uh, just the way of writing, the variables are changed. Okay, you have to replace v with a omega, s with a theta, and a with alpha, because we are talking about the angular velocity, angular acceleration, angular displacement. Okay, nothing is different here, but remember that these formulas are applicable for constant acceleration, right? Because alpha is not changing here, it is constant. Okay, considering this, I'll give you one or two questions so that you will you are habituated with this kind of questions as well. A point describes a circular path of radius 1.2 meter. The angular velocity and angular acceleration. The angular velocity and angular acceleration of the radius of the point of radius of the point r 6 radian per second and 3 radian per second square, both clockwise. Stop. If the angular acceleration is constant, determine for a given instant and at 6 millisecond and at 6 second later the normal and tangential components of acceleration of point of the point and the angle turned through in 6 seconds. Okay, let me read this question again. A point describes a circular path of radius 1.2 meter. The angular velocity and angular acceleration of the point are omega naught is equal to 6 radian per second and alpha is equal to 3 radian per second square. Okay, both clockwise. If the angular acceleration is constant, determine the velocity and determine for a given instant and at 6 seconds later the normal and tangential component of the acceleration. So what they're asking is at the same instant and after 6 seconds AT and AN they are asking you. Okay, you know AT is what? AT is R times alpha and normal component of acceleration is R omega square. Okay, so at that instant it is very simple, nothing to do, just put in the formula and get the answer. But after 6 seconds you may need some equations of motion and you have to apply it in order to get it. Okay, so at that instant what is the answer? What is velocity and acceleration? Sorry, what is the tangential component of the acceleration and normal component of the acceleration? Fast, it's not that difficult. R is what? R is 1.2, alpha is 3, so it's 3.6 meters per second square. R is 1.2 into 6 square, it is 43.2 meter per second square, right? But what about now after 6 seconds? Can you tell me now the acceleration AT and AN after 6 seconds? Anyone? Yeah, correct. So in order to get that, you should first calculate the 691 is correct, but in order to get that, you should calculate the omega. Omega is equal to omega naught plus alpha t. V is equal to u plus at, we know, right? So 6 plus 3 times 6 is 24 radian per second, and so it will be 1.2 into 24 square is 691.2 radian per second. Your tangential component of acceleration will remain same because it's a constant acceleration problem, 3.6 meter per second square. Okay. Uh, what about this last point? The angle turned through in 6 seconds. Theta they are asking. What is the value of theta? Ut plus S is equal to ut plus half a t square, right? So omega naught t plus half of alpha t square. So omega naught is how much? 6 into t is 6 seconds plus half of is alpha is 3, t is 6 square. Okay. So 6 multiplied by 6 is 36 plus 6 square is 36 divided by 2 is 18. 18 multiplied by 3 is 54. 54 plus 36 is 90 radian. Okay. So answer in this case is 90. So are you following? So whenever question comes in case of, let's say, uniform angular acceleration, you should not worry. You apply the same set of formula. Okay, and same is applicable for the variable acceleration problem. Okay, in variable acceleration problem also you don't have to worry. Same approach. Differentiate with respect to t. You will get the, so you know theta, omega you will get it as d theta by dt. Okay, and again if you differentiate you will get alpha, that is d omega by dt. That's all. Okay, so approach is same, just your um, way of calculating or just your writing variables are different. Okay, the way you are writing the variables. Let me give one question so that you will be aware. The angle of rotation of body is given by theta is equal to t cube minus 4t square plus 10t plus 5, where theta is expressed in radian and t is in seconds. Determine first angular velocity and angular acceleration. Second, acceleration of body at start, angular velocity and angular acceleration body after 5 seconds, and third is angular displacement in 4th second. Displacement in 4th second. Okay, solve this. Okay, again very simple question. Just the variable acceleration. It's not a constant acceleration problem. So you cannot apply the equations of motion v is equal to u plus at, s equal to ut plus half at square and all. Okay. Okay, so yeah, some of you already solved. Yes, omega naught is 10, alpha is -8. Yeah, after 5 seconds. Initially, it is very simple. Let me go to the next slide, and to solve it, theta is equal to t cube minus 4t square plus 10t plus 5. So omega will be equal to d theta by dt. Okay, omega is equal to d theta by dt. That is 3t square minus 8t plus 10, and alpha is equal to d omega by dt, and that is equal to 60 minus 8. Okay, so at start means at t is equal to 0, theta will be equal to 5, omega will be equal to 10, and alpha equal to -8. That's all, because just put the value of t in these three equations. Equation number 1, 2, and 3, you will get the values of theta, omega, and alpha. Okay, they are asking you only omega and alpha, so you can call it as omega naught. That's all. What they are asking next is, and let's call it as alpha naught. What they are asking is angular velocity and acceleration after 5 seconds. Okay, so omega 1 will be equal to 3 times 5 square minus 8 times 5 plus 10, that is equal to 45, and acceleration again alpha is equal to 6 times 5 minus 8. Okay, that is 22 radian per second square. This is radian per second. Okay, so this is your first answer. This is your second answer, angular velocity and acceleration after 5 seconds. And third is angular displacement in fourth second. So in fourth second means angular displacement in 4 seconds you have to calculate. That is theta 4 you have to calculate, and theta 3, and then you have to calculate theta 4 minus theta 3. So that will be angular displacement in fourth second, because theta 4 is angular displacement in 4 seconds and theta 3 is angular displacement in 3 seconds. So if you subtract that, you will get angular displacement in fourth second. Okay, so theta 4 is 4 cube minus 4 into 4 square plus 10 into 4 plus 5, and that is equal to 64 minus 64. So this will basically get cancelled out. 45. Theta 3 is 3 square minus 4 into 3 square plus 10 into 3 plus 5, and that is 3 cube, sorry, here. 27 minus 36 plus 30 plus 5 is 26 radian. Okay, and it is 45 minus 26, it is 19 radian. Okay, so that's all. Yeah, some of you already answered it. Let me give you one more question on the same angular velocity acceleration approach. A wheel rotating about a fixed axis at 20 revolution per minute is uniformly accelerated for 70 seconds, during which time it makes 50 revolution. Find first angular velocity at the end of this interval. At the end of this interval. Second, time required for the velocity to reach velocity to reach 100 revolutions per minute. Okay. Yeah, I will wait for 2 minutes. You try to solve it and tell me the answer. Yeah, solve this question. So here this is more or less same. Only thing is that they have not given angular velocity directly. Okay, indirectly they have given you. So think on it and solve it. First of all, they are asking you to calculate the angular velocity at the time of this interval. Number of revolutions are given. Make use of it in order to calculate the omega. Okay, omega is 2 point. No, Purnia, something is wrong. Let me help you out. So omega naught is the initial angular velocity. Okay, and what they have given is the wheel is rotating about the fixed axis at 20 revolutions per minute. Okay, uh, so 20 rpm is the velocity. So in order to convert into radian per second, what you do is 2 pi n by 60, right? So 2 pi n by 60, if you do, you will get it in radian per second. So 2 pi into 20 divided by 60 will give you 2.094 radian per second. This is the omega value. Okay, and this is uniformly accelerated for 70 seconds, during which it makes 40 revolution. Sorry, 50 revolutions. So theta is what? 50 revolutions. So 2 pi into 50 will be close to 314.15 radian. So this much angular displacement it has traveled in 70 seconds. Okay, this will give you way to calculate the angular acceleration alpha. Okay, so you know theta is equal to omega naught t plus half of at square. Theta is already known, that is 314.15, and omega naught is how much? 2.094 into t is 70 plus half of alpha times t square, that is 70 square. If you use this, you will get the value of alpha. 0.0684 radian per second square. Okay, this is how you will get the alpha. What they are asking is to calculate the omega, that is the angular velocity at the end of the interval. So omega is equal to omega naught plus alpha t. So that is equal to 2.094 plus 0.0684 into 70 will give you the value of omega, and that is 6.882 radian per second. Okay, if you want to convert it into the RPM, so omega is equal to 2 pi n by 60. N will be equal to omega into 60 divided by 2 pi. So 6.882 multiplied by 60 divided by 2 pi. This will give you the RPM value. It is close to 65.718 RPM. Okay, and what else is they are asking is the time required to reach the velocity of 100 RPM. Okay, 100 evolutions in per minute means 100 RPM. So omega 1 for the second problem, they are given us as 100 RPM. So this should be equal to 100 into 2 pi by 60. It is 10.472 radian per second. So we got the omega 1. So V is equal to U plus 80. And or in this format, that is omega is equal to omega naught plus alpha t. That is 10.472 is equal to omega naught is 2.094 plus alpha we just calculated 0. How much 0.6 0.068684 into T1. So T1 is equal to 10.472 minus 2.094 divided by 0.0684. Okay, so should get around 122 seconds, around so 2.04 minute. Okay, I hope it is clear to you all. Yes, Deepashri, your answer is closer. Okay, we have some more time, so let's take one or two more questions. A string 150 125 centimeter, sorry, 125 centimeter long, can just support weight 5 kgs, okay, weight of 5 kg, a mass of 6.33 kg is tied at its end and revolve uniformly on a horizontal table. Revolves uniformly on a horizontal table. The other end of the string being attached to a fixed point, on the table. Find the maximum rotational speed in RPM. Find the maximum rotational speed in RPM attained by the string without breaking. Okay. Okay, try to solve this question. A string which is, let's say, r is equal to 1.125 centimeter or 1.25 meter can just support a weight of 5 kgs. Okay, but a mass of 6.33 kg is tied at its end and revolves uniformly on a horizontal table. Okay, the other end of the string is being attached to the fixed point on the table. Find the maximum rotational speed in RPM attained by the string without breaking. So maybe this is the circular motion of the string. This is the fixed point. Let's call it as P because of this weight, and T is in the tension. And let's say it's rotating in this direction omega. Okay, so try to think on it and solve this question. Okay, see, if you attach something to a string and which is revolving in a circular motion, a centrifugal force P will be get created. So this P is nothing but the centrifugal force. Okay, and the value of it is mr omega square, and the T is tension in the string. So with this hint, try to solve this question. No, Weber. 75 is not correct. Um, so in RPM, you have to calculate answer. Okay. In RPM, they have mentioned it. Yeah, I'll wait for 1 more minute. see what is the use of this 5 kg. If you remember, uh, they have mentioned can just support a 5 kg weight. So tension in the string will be 5 into 9.81. Okay, the centrifugal force mr omega square should be equal to T times Z only. Okay, um, because it can just support the weight of 5 kg. Um, omega, if you want to calculate from this, it will be under root of T times G divided by M R. Okay, so it will look like as 5 into 9.81 divided by M is equal to 6.33. Okay, because 6.33 kg of the weight is tied to the end of the string, and it is rotating, revolves uniformly on a horizontal table into 1.25 is the radius of the or the length of the string, you can say. And if you calculate it, you'll get around 2.49 radian per second. And then in order to convert into the RPM, 2.49 into 60 divided by 2 pi, if you do, you should get 23.77 RPM. Okay. So 23.77 is the correct answer in this case. Yes, correct, Punya. You are right. 23.77 is the correct answer. Yeah. Now one more question I'll give before we end. Just a short question. We have, I think, yeah, one or two, some more time. Let's take one or two more questions. Body A of mass 5 kg moving along a straight line with velocity 5 meters per second strikes another body B of mass 10 kg at rest. If the bodies are perfectly plastic, if the bodies are perfectly plastic, determine their velocities. Determine their velocities and loss of kinetic energy after the impact. After the impact. Okay. This is on the concept which I have explained to you just some time back about the perfectly plastic, inelastic or perfectly plastic collision. So use that approach to solve this question. Solve this. Okay, and after this, I'll give one homework question. Anyone have solved it? It's a perfectly plastic bodies. Momentum is conserved. Perfectly plastic bodies means what? E is equal to 0. Okay, remember this. So velocity after the collision will be same for both the bodies. Okay, we have studied this before, so it shouldn't be a problem to solve it. And what they are asking is loss of kinetic energy. That formula also I have given to you. Loss in kinetic energy is kinetic energy before impact minus kinetic energy after impact. So it's a very simple question. You should be able to solve it. So what is the value of the velocity? And loss in K? First answer is in meters per second, and second one the joule. Okay, let me help you out. MA UA plus MB UB. It's the momentum before the impact, and that is equal to MA plus MB times velocity, moment after the impact. So its momentum is conserved. Conserved. So 5 into 5. Body A is 5 kg, moving with velocity 5 meters per second, plus body is 10, with 10 kg body B, which is at rest. So 10 into 0 is equal to 5 plus 10 into V. So V is equal to 25 divided by 15, which is close to 1.667 meters per second. Okay. Second part of the question is loss of kinetic energy. K before impact. Loss in kinetic energy is K before minus K after. K before is 1/2 MA UA square plus MB UB square minus K after the impact is 1/2 MA plus MB V square. Okay, so it is half of 5 into 5 square plus 10 into 0 square minus half of 5 plus 10 into 1.667 whole square. Okay, so it's 5 into 5 square. 5 square is 25 divided by 2, 12.5 into 5. Um, so minus, again 15 by 2 is 7.5 into 1.67 whole square. You should get close to 41.65 joules. Okay, 41.65 joules. Yeah. Yeah, some of you already answered it correctly, but yeah, this is the way to solve it. You should be aware of this plastic collision elastic collision and partially elastic collision. Okay, so that is the overall intention behind this problem. One more question I'll give for homework. You try whenever you get some free time. A thread is wound around a homogeneous cylinder of weight W and radius R as shown in figure. As shown in figure. Full stop. The cylinder is allowed to fall from rest and fall from the cylinder is allowed to fall from rest and unwinds the thread. Full stop. Determine first the angular acceleration of the cylinder and second one is tension in the thread. Okay, solve this question. Let me draw the diagram. Okay, like this. W, O, and let's this is the R. Okay, tension. Okay, the thread is wound around the homogeneous cylinder of the weight W and radius R as shown in this figure. The cylinder is allowed to fall from the rest and unwinds the thread. Okay, so you can imagine like the thread is getting unwind. What they are asking here is to calculate the angular velocity of the cylinder, angular acceleration of the cylinder, sorry, alpha. The answer for this is 2g by 3r. And second one is the tension in the thread. For that, you should get W by 3. Okay. Solve this question during your free time and check your answers with this. You should match the answer. If you face any difficulty, feel free to reach out to me through WhatsApp, or you can post it in group as well. I'll send the solution. Okay, so that's all we have for today. In the next session, we will study the remaining topics, virtual work and Lagrange theorem. And after that, we'll have one more session where I'll bring some more questions from overall syllabus. Okay, so that's all we have for today. And thank you all for joining this class, and let's meet again next week. Thank you all. Bye. Have a good Sunday. I will upload all the PPTs today, okay, and to the drive. And once I'm done with it, I will post it in the Teams. Sorry, in our WhatsApp group.